everyone, welcome back to another video, and in this video we are starting a complete Kubernetes course from scratch. No prerequisites whatsoever about Kubernetes are required. We're doing the complete DevOps bootcamp, so make sure you check out the links in the description. We've already done videos on like basics of like Linux and networking and complete networking tutorials and courses and Docker as well, and about containers and all these things. So make sure you check out the link in the description. In the playlist section you can find the DevOps bootcamp. You also have the data structure algorithms bootcamp for interview preparation, but right now we're starting with Kubernetes. If you don't know anything about Kubernetes, this video is for you. We'll cover everything like how it started, the architecture, how you can use it, so like the installation, what problems it's solving, the features, various terminologies, and hands-on demos as well. So if you don't know anything about Kubernetes, by the end of this video you will know a lot, right? So in every video that I make on my channel, you can find so many tutorials. I make sure that I am explaining things in such a way that even a person who has never heard about that thing, so if you have never even heard the name Kubernetes, you will be able to understand this video very easily. All right, so let's get started. So in the previous Docker video, I mentioned like why we're using Docker, right? And what used to happen before, like they were like, if you want to start a new application, for example, so in the previous days, you had to get servers, you had to buy servers, right? And you install a server and then you put your application in it, and your company is like, hey, we need more applications running. You're like, okay, let's buy new servers, add applications onto it and whatsoever. Okay, so it became really difficult. It became really cost consuming and time consuming, and developers were focusing on development, like building the application, building their project, website, apps, or whatever. And the people installing and managing these servers and stuff, they were responsible for sort of like running applications on this. So sysadmins, for example, they were extremely crucial in handling these servers, is basically what I'm saying. So in the Docker video, we learned about this. In the Docker video, we also saw that then we got something like, virtual machines. So in the virtual machine part, we saw that now you can divide your space and allocate resources and CPU and memory usage to like virtual machines. Okay, so you can divide your hard disk, for example, install another operating system of that will act like a separate machine. So in one server you are having many machines. That's why it's called virtual machine. This way you don't have to buy new servers, you can just use that server only as different machines. But this was also not cool. And then we learned about containers, right? So containers basically say, okay, you will run your applications in such a way that your application is isolated from the outside world. But the very awesome thing is that you would not have to install a new operating system, allocate resources to it, or whatever things like that. It will run on the host operating system only using some container engine. That is something we learned about in the previous one, which was Docker. Please watch the Docker tutorial, and we will, we covered everything over there, like how we sort of like started. Cool. So what happened was, okay, so around this time, one more thing also came, which was known as configuration management. Configuration management. So this basically means that you can maintain all the changes in your infrastructure with the help of software. Okay, so for example, you have Ansible and stuff. So basically you can provide a state like, hey, I want my infrastructure to run like this and like that. This much RAM should be allocated, this much that should be allocated. But in the previous wave, like before virtual machines, we used to have like these racks of servers and stuff, right? So the configuration management tools were like built for these. But then came into picture virtual machines. The virtual machine is like that we are offering you dynamic infrastructure, like you can scale up or down or divide your resources in the same server. Okay, so what they told was that, okay, if you're running like stuff on virtual machines, then when you have your configuration, let's say installed or whatever, you're running your desired state, you're like, okay, I'm running this application like this and like that, it's running, people are using that, and I'm going to make changes to that application, that image that is, let's say container that is running. So it's not like you can change the container at runtime. These particular configuration managements were first like they were mutable, like you could change those, but now it's like it's immutable. So for example, if it's already running, like container running, can't change that. If you want to make some changes, you can start up a new virtual machine, for example. Okay, so it's provided immutability, which is important because this will something we'll talk about later when we talk about like containers. You want to start new container, you want to add a new version of your application. Okay, stop the previous containers and start new containers. So at runtime, you cannot make changes as such. And this is how the modern infrastructure works. Okay, so now you know there are so many cloud hosting platforms, right? There's Civo, there's AWS, Google Cloud, Azure, DigitalOcean, Linode, so on and so forth. So many cloud hosting platforms. So you can run your own applications in the cloud and all these other things. They offer like Kubernetes services and all these other things as well. So managing the modern infrastructure, it's based on immutability. You want to make some changes to like the virtual machine stuff. You want to update your application. Previous ones will go down, new ones will come up. Okay. See, I'm just telling you like the history right now. Then we'll go into the details of it, and don't worry about Kubernetes right now. First, let's see what happened and why we are doing what we are doing. Okay. So stuff like, you know, Chef, Puppet, so on and so forth. All right. So these are basically infrastructure as code principles. So it's very simple. Don't worry about it. We'll cover more of these later on in like a separate infrastructure code video, but I'll give you a basic explanation in this as well. So as I mentioned, like you mentioned, okay, basically writing your configuration about your server in a file and like saying that, okay, I want my server to be like this and like that. Okay. So a little bit of history. Previously it was mutable, like you can make the changes to your running bare metal like servers that were running that you know, before virtual machines. When virtual machines came, they were like, okay, now I have like as many stuff as I can create, because before, like during virtual machines also, what happened was that like an application that requires, let's say, 2 gigabytes of RAM, but the virtual machine is allocated 10 gigabytes of memory, 8 gigabytes is wasted, for example, right? So immutability basically meant that it is offering some reliability as compared to your previous, you know, before virtual machine scenario. So it offers reliability, and it was also much more, you know, better in terms of like securities and stuff. So you cannot change anything that is already running. If a virtual machine is running, then you cannot change that. If you want to make some changes, you have to create a new virtual machine, let's say make some updates to your applications and whatever. Okay, but with configuration management tools, like they are providing like, okay, I can now make, you know, specify some things that I want a virtual machine to be running with this much amount of memories. I give that file and the server will start that. The problem is that what if like in a server you are running multiple services in one server? Some is requiring, let's say, Python 2, some is requiring Python 3 or whatever. Let's say, just giving an example. So one service, like there are many services running of same type but requiring different versions. Different versions are being required. So what do? In a release, you just say make a folder, zip that and share that as a release, manually copy files and whatever. Are you able to understand? So you may have heard about in development package managers. Package managers. Previously there were no package managers, and this was the issue with that. Okay, like what if one application is running and you want to have like, it's one particular app is service is asking for Python 2, another is asking for Python 3. It's all running on one server. So which one? It's like so hard to manage, right? So then came into picture like, okay, what we need to do is we don't need to have a separate virtual machine for every service that we are running. Are you able to understand? Like just servers, okay, virtual machine. So separate virtual machine can run every single application. You're like, okay, no, I don't want to do that. Okay, I don't want to do that. I can instead have containers. Okay, so then came into picture containers. So using containers, you can spin up containers like that. All the, you know, things that you can bundle, the version and modules, OS and everything, you can get a Docker image or whatever, deploy it, and it can run on servers and whatever very simply. So we talked about containers in the previous video, but let's talk a little bit more about managing containers. So this video is about that. Okay, so let's talk about now managing containers. Managing containers. So some important terms I would like to mention over here before we talk about Kubernetes. Let's first talk about how applications were like structured in the previous days. So there's something known as how it used to work was monolithic applications. I'm writing so many terms in my whiteboard, and I personally never make notes. Okay, all the important things I'm mentioning over here, the most important things I'm actually saying. So it's up to you to make notes and everything, but I would not recommend making notes. Just put it in your mind, understand it, Google whenever you have any doubts. Okay, monolithic applications. It is very simple. So monolithic architecture basically means that you have, let's say, talk about a website. Okay, what do we have in a website? What do we have in a website? We have the front end, we have the back end, and we have what? We have, let's say, some messaging, chat messaging application, chat messages or something, and we have a database, for example, right? And we have some networking components, for example. Okay, so five components we are having in a particular web application, simple web application. If you bundle this as a single application, all the code as a single application, Kunal, what do you mean bundle as a single application? What do we mean bundle? Bundle basically means, like, in simple language, deploy it as one application. Okay, in your container, just deploy it as one application. In your container only, everything will be running. Front end, back end, chat, app in one container, database, everything running in, just bundled together as one application. Okay, this is known as monolithic application, monolithic architecture. Okay, it's very easy to deploy. You don't have to do anything, just simply deploy it, and only one thing is running. Okay, and since it's everything is deployed as once, so if you want to make any changes, let's say in database, you'd have to deploy everything entirely again. You want to make any changes into networking code, you have to make changes in networking code, deploy all the things again, because all the things are together. Okay, here was a little bit, this was a problem. Okay, if you want to make little bit of changes in the back end, you have to deploy front end, back end, chat, database, and networking all together at once. Okay, if you want to scale front end, you would have to scale back end also. Let's say my front end, my application, this entire application is running right now on 3 servers. You want to put it on 10 servers. You want the front end to be only on 10 servers. You don't want all these other applications on 10 servers. But these are one application, it's bundled together. So if you want to scale front end, it will automatically have to scale all these other applications also. Okay, so this is not a very good design. This is not a very good design. So this is basically what we call monolithic application. Okay, so how do we solve this problem? Microservices, very, very important term. We'll be playing with microservices a lot on this YouTube channel. Okay, microservices, microservices, very simple, as the name suggests. Now basically the idea is that instead of deploying it as a single application, all of these components are deployed as individual applications. Front end, back end, chat, let me write it down. Front end, this is simple, different application, okay, deployed differently. Back end, database, and messages. What else did we have? Networking components. How cool is that? Okay, all the problems we were having. Now, for example, you want to make any change in front end. You're like, let's say this is running on server number 3. This is running on server number 2. This is also running server number, just in an example point of view. Okay, don't quote me on this. Server number 1. So you want to make changes to front end, you will only change this front end application that is running rather than all these applications that are running. You want to scale front end, you want to have 10,000 applications of front end and only 5,000 applications of back end and 8,000 applications running of databases, or 8,000 containers running of databases, right? That is totally cool now. You can do that, since this is running in its own container, this is running in its own container, this is running in its own container. Okay, and the previous thing that I mentioned, the lack of package managers, like all these things like dependencies and whatever, that is being solved now with Docker. That is being solved now with Docker. Every container has no idea what's going on outside it. It's running on its own. Okay, so please have a clear understanding of this history. Bare metal servers, virtual machines, containers, monolithic, microservices, and this thing. The configuration management tools, and how that worked with mutability and immutability. Very nice summary I gave you just now. Cool. But the problem here was that obviously we are solving some of the problems, like how are we going to run these so at so many other places or whatever? So containers, you can use containers and run your microservices inside containers. You can scale those independently and all these other things you can do. Okay, you can make change in one application rather affecting with other application. This is also called isolation of fault isolation. Fault isolation. I can make changes in the front end code. You can have some people working on this code, some people working on this code. So now teams can also be divided, right? Teams can also work on their own. But the problem is how to manage. Because if these applications are running separately, obviously it is all a part of one application only, right? Theoretically. So they would have to communicate with each other. Right? So how to manage this? How do they communicate with each other? Because if you're running 10,000 services, so that can become a very complex graph, right? This application talking to this application or whatever, that can be very complex. Okay, some of the tools, like there's also something known as, later on we'll look at service meshes. I am actually having a like this now. Okay, service mesh later on. Cool. So we're looking at service meshes in the future. Cool. So I believe you have this understanding about virtual machines and containers now, that virtual machine, one application on one virtual machine. This is not cool for scaling. Hence Docker. That's as simple as that. Okay. All right. So we have looked at a bunch of things. Now the next part, scaling these applications, right? So let's say you have so many containers that are running. Okay, talked about microservices, your microservices, individual applications running inside containers or whatever they are running so nicely. And let's say your website is running 100 containers. Now some more people start using your website, so the server load increases, right? You want to have more and more instances of your applications. Now you're like, okay, create more applications and distribute the load over the servers. Okay, something like that. So how would you do that? You can do that, like just one command and just start all these other things. Then what you can do is one problem you may face is you want, so let's say you're running 1000 containers and 200 containers get damaged or something. You want to restart those. So that's also another problem. Let's say you have something like you want to make updates to your application. Version 1 is running, you want to have version 2 updated. So what do? Would you stop all the things, make the update, then start your services? Then your customers will be mad, right? They'll be like, okay, what is happening? Why is the application down? So folks often want to update the application while it's running. Okay, so rolling updates or like rollbacks with zero downtime. Okay, and scale it up and down accordingly, and also deploy your applications, for example. So how can we do that? Comes into picture orchestrators. Orchestrator. So orchestrator basically helps us in deploying and managing applications. Okay, dynamically. Deploying and managing applications dynamically. Dynamically means like on its own, with the use case that is provided. More people are using, scale up the application. Some things went down, then restart it, heal the containers or whatever. Okay, managing containers dynamically. Kubernetes helps us in doing this. Okay, so you can deploy your, please make notes on your own. Okay, you can deploy your application, you can zero downtime, updates, in scale your application, right? And you can heal containers when some containers go down or whatever. You can restart those containers, so many other things. Okay, and Kubernetes helps us in doing this. And by the way, these are all also features of cloud native applications. Cloud native applications. I'll dive deep into Kubernetes obviously, but try to understand what orchestrators are. For example, like if you have you have the orchestra where someone is playing trumpet, someone is playing the drum and whatever, and there's this person who is the orchestrator or whatever, they are doing like this in the music hall. So it's like managing everyone. Okay, that person doing this is Kubernetes, an orchestrate. And those people who are running like playing trumpets and drums and guitar and whatever, they are microservices. Okay, so Kubernetes is managing the microservices. Okay, so if someone asks you now, Kunal, what is the difference between like what is cloud native? Is it same as like cloud computing or whatever? No, it's a different thing. Cloud native basically means the cloud native applications that can run modern business in the modern business, how the modern business functions and meet the modern business demands. For example, right, Kunal, what are those demands? These are the demands: deploy, zero downtime updates, scale, heal the self-healing, for example, self-healing applications that follow all these principles, and applications that can run on top of Kubernetes. That is a most important point. These are known as cloud native applications. Okay, it's different than like cloud computing. Cloud computing means you're taking some resources from some cloud provider like RAM or server or whatever. Definitely cloud native applications can run on these cloud computing platforms also. Okay, it can run in your local system also. Anywhere you have Kubernetes, you can run cloud native applications. Hope you're able to understand what cloud native is. Okay, cloud native applications that are designed to meet these requirements are called cloud native applications. Okay, so this will also make sense now that running containers directly like that, it's a bad idea. Okay, no one is like running just containers as it is. They're using some orchestration tools, some scheduling tools, and Kubernetes provides us that. Okay, scheduler basically means that schedules all these containers and manages all these things. Okay, so these are some like some of the benefits, right? So when we talk about Kubernetes, it has schedulers, and basically it's makes sure, scheduler is basically something that makes sure like, okay, Kunal, you told me that 5 applications should be running. Always 5 applications will be running. If one goes down, I will restart it. Scheduler takes care of that. Scheduler like, okay, Kunal, you mentioned only 2 GB of RAM should be allocated to this application. Sure, I will take care of that. Okay, so it will make sure like all these fault tolerance and like the high availability and self-healing stuff that takes into picture. Okay, so cool. Okay, so that's basically what Kubernetes is. I'll talk more about the features, how it started and everything. We haven't even touched upon K8s right now. I've just mentioned what orchestrators are, and Kubernetes provides us in such a way. So for example, you can say that, hey, you can tell it, like what we want it to do rather than how to do it. Okay, so you don't care how it does it. So like, hey Kubernetes, run this application, this website application on 2 servers, okay, behind it, okay, and allocate this much memory to it. How it will do it, that's up to Kubernetes. You just provide it via an API. Okay, Kubernetes API, and I'll tell you about that API in just a minute when we do hands-on coding, and how we'll actually use Kubernetes in this video itself, schedule some containers and all these things that we are mentioning. Okay, so that's basically it. That's Kubernetes allows us to do all these other things, and if applications are like going down, Kubernetes will help get those restarted. You can deploy applications with zero downtime updates, scale those applications, self-heal these containers, and it also provides a lot of amazing features. Okay, an application that is running, you can duplicate and replicate that application. It also offers like load balancing services and everything. So orchestration provides these features. Okay, but Kubernetes on top of that also provides some additional features. So can we say that Kubernetes is much more than a container orchestrator? Yes. So this is an important point. If someone asks you what is Kubernetes, you should not say it's a container orchestrator. No, it is much more than that. Okay, you can run it on your own cloud. Write down these points that I'm saying. So you can, for example, run it on your own cloud or some on your own machine or outside in the public cloud providers as well, right? And you can migrate it, so you can migrate from one provider to another provider. You can also when we're talking about like services, so Kubernetes can replicate those and scale those and like put those on like dedicated like servers and stuff, and the zero downtime deployment stuff and fault tolerance and self healing of clusters and everything that is mentioned over here. You can also use volumes with it, so that's also some additional. So you can use volumes, right? Some external hard disks or whatever, external storage. It also provides load balancing, right, for requests and stuff, and you can access logs, and then there's service discovery and all these other things. You can also store what's it called, the secret information like password and stuff using secrets, for example, right? So many things that I mentioned, that is much more than orchestration, right? It's much more than orchestration. So that is why Kubernetes, it's extremely popular, and it's much more than a container orchestrator. Okay, now let's talk about, so the features of Kubernetes now or whatever, but how it works and the architecture and everything we'll look into shortly. But before that, let's see how it came into picture. It's a very nice story actually. So like what happened was that when people were running like bare metal like servers and stuff and all these other things, came into picture AWS, Amazon Web Services. They changed the game. They offered something known as cloud. So AWS offered cloud, and everyone lost their mind. So people are like, hey, this is all fake and cloud is nothing and everything, but AWS kept going, and then they sort of like dominated the market. And then what happened was that there was obviously some competition, and there was this thing known as OpenStack. Okay, so OpenStack was more like an open source alternative for AWS, but it did not like work out. Okay, so it did not like, could not catch up to like AWS. AWS was already on a really large scale. Before everything like this was happening, Google internally in their own company, like they were running containers and orchestrators on a very large scale. Billions and billions of containers Google was running. Okay, they were using their their orchestrators and something known as, I believe, Borg, okay, and Omega. So these were, people were offering their own stuff and whatever, but Google was running these billions and billions of containers and orchestrators and stuff, the things that I just mentioned above, privately in their own company. Okay, then what happened was that Google created Kubernetes, and the folks who worked on Borg or Omega, I believe they created Kubernetes. It's not like the same thing, but I believe like since the same people worked on it, maybe like has some sort of a similarity, but don't really know. So they donated Kubernetes. So Google made Kubernetes or K8s. It's called K8s because Kubernetes, first letter K, last letter S, in between it has 8 letters. So K8s in short. Google made Kubernetes open source in 2014 and donated it to CNCF, Cloud Native Computing Foundation. Shout out to CNCF, and also check out CNCF students if you want to get involved. Contributing to open source, it's I believe the second largest project after Linux open source project. So you can contribute to it. Even non-code contributions are welcomed. I made videos on this, like how you can contribute, Shadows program, and all these other things. Make sure you check out the Open Source Cafe playlist. I've done some amazing videos on how you can contribute to K8s. That's how Kubernetes came into picture. Okay, so it was donated to CNCF in 2014. So you can see it's not that old. That is why the number of jobs and opportunities in this field is very much. I work in the field of Kubernetes as well, and I'm a student, and it's just amazing. Like, I love it. Cool. So many opportunities, and the pay is great as well, and everything is amazing, and exciting technologies and stuff you can work on. KubeCon is coming up, so shout out to that. Okay, so that's sort of like the history, and Google donated it, and now it's open source, so many maintainers and stuff, people like us and you, we contribute to it. Okay, some people also say it as an OS of the cloud because you just run your app, you write your application for Kubernetes, you don't care where it's running. Then I don't care if it's running on like AWS or whatever, or Google Cloud, or you can also run it on Civo and all these other company, Linode or DigitalOcean. It doesn't matter. Like you can check out, like you can write your application and then you can deploy your K8s application in various platforms. We'll be using Civo because it's extremely fast. extremely affordable as compared to other cloud providers, and it's just awesome. So you can get $250 worth of free credit. Make sure you check out the links in the description. This is going to be important in the future because when we use when we try to work with various servers, you can't install various, you cannot have various servers on your machine, because how much your resources will be depleted, right? Your computer is not that fast. That's why we use cloud providers. Some students are a little bit annoying. They say, oh, it's asking me to put my credit card. Dude, this is basic knowledge, right? No cloud provider will let you access their resources without a card. It's basic security check, okay? Because otherwise folks will um, you know misuse the resources. You're giving access to your infrastructure, okay? That's why a credit card, or like a card, it is always required any cloud provider you go to. If you want to learn, you would have to add your card. Please, it's basic common sense. Don't ask me weird questions. Okay, and the name you can talk about, it comes from a Greek name, I believe, Helmsman or something. So you can check it out. Okay, so it's like the person who's steering the wheel, like in the ship, and that's why the logo is also a helm type ship. I'm wearing a helm hoodie as well. We'll talk more about helm in the helm tutorial later on. So that's basically about it. And in the Docker video, I also mentioned that when we're talking about, okay, Kubernetes is managing our containers and stuff. Kunal, what is the difference between like Docker and Kubernetes then? Docker is a container tool, and Kubernetes acts as an orchestrator. Okay, you were able to use like Docker, but now it's like sort of like deprecated. Why? Because there's a container runtime interface. CRI, container runtime interface. In the Docker video, I told you about container runtimes, container D and all these other things, right? And the thing is that it's like Kubernetes is allowing you to use various container runtimes like container D and stuff. And but it's not allowing like Docker now, because it does not comply with the the standards of this thing. Okay, it complies with the standards of OCI, Open Container Initiative. Everything is covered about this in the previous video of Docker. It's a very awesome video and nice long in-depth video. Please check it out. Okay, so the Docker shim removal stuff that I mentioned, that's basically about it. Now you can use container D, for example. Question will be like, Kunal, if Docker is not supported in like Kubernetes or whatever, what does it mean? Can I not run my Docker like images and stuff? No, the answer is like you can definitely do that. Answer is Open Container Initiative. I've answered this question in the Docker video. Doesn't make sense to repeat it again and again. So make sure you check out the Docker video. Okay, but let's move forward and see how, like, a little bit more about K8s, like Kubernetes, what it is. Like, we've learned about what it is, and let's see how it works, architecture, some demo, how to install it, how to use it, and some additional tools I'll also share that will make your life extremely easy when learning Kubernetes and also working in production. There's also, I believe, a story related to Star Trek. In Star Trek, there's something related to Borg. I'm not entirely sure, but due to copyright claim, they were not able to get that. You can Google that history yourself. Alrighty, now important part. This is a new part in this video, which is we are starting now. This is architecture of Kubernetes, how Kubernetes works, various components, and after this we'll do a demo. So you might have, in this part of the video, it's an important part, so we'll talk about various terminologies as well that you may have heard. Kubernetes cluster, control plane, worker nodes, kubectl, pods, containers, runtimes, so many things. So we'll cover everything, what they do, how they communicate with each other. We'll draw nice diagrams, explain everything in an easy to understand manner. By the way, if you like this video, make sure you like, share, and subscribe as well. And yeah, let's get started. So Kubernetes is very complex. It has so many components and everything. But the good thing is that it is very good at abstracting these things. Like, we only tell it what to do, how it does it internally, like it manages on its own. But since you're learning about Kubernetes, it's important to let's say understand how things are working. Yeah, let's get started. So when we talk about terminologies, let's talk about the Kubernetes cluster as a whole. Talk about Kubernetes cluster. cluster. Kubernetes cluster. So Kubernetes cluster basically means that you have your own, a bunch of nodes and a control plane. So Kubernetes cluster means control plane plus nodes. Don't worry if you don't know what a node is. Don't worry if you don't know what a control plane is. Okay, we'll cover that right now. A node can be treated as a virtual machine, for example, right? And a control plane, which was previously known as master node. Okay, but now master is not a good naming, inclusive naming convention. So it has been changed to control plane. So in short terms, there's a control plane, or previously known as master node, control plane, and there are worker nodes. I'm gonna put it like this. Worker nodes. So what happens is that the nodes thing, Kunal, what is this control plane? Where is it? What is this worker node? Where it is? So this node thing that I'm talking about, individually you can imagine these as servers or virtual machines, whatever you want. Servers, as for example. Okay, worker node is the place where your application will be running. Control plane is actually going to manage the worker nodes. One more thing I wanted to mention here. This is the control plane, and this is the kubectl, which communicates with control plane, which is the CLI tool. Like in the Docker, we had Docker run whatever. Here we have kubectl run whatever. Let me explain it to you. Okay, don't worry. I have written so many things. I'll explain in a bit. Okay, let's talk about it. Okay, so Kubernetes cluster is this thing. This entire thing is a Kubernetes cluster. Someone asks you, what is a Kubernetes cluster? It's just a collection of worker nodes and the control plane, which was previously known as master node. From now on, I will only call it the control plane because it is known as that, because master node is not inclusive naming convention. So it was renamed to control plane. Okay, so cluster is clear. What is a cluster? We'll talk more about what control plane is, what worker node is, what kubectl is later on. Cluster basically means collection of all the control plane and nodes. That's it. Okay, now let's dive deep into what is this kubectl, what is this control plane, what is this worker node. Okay, let's first look into kubectl. What is kubectl or kubectl? Kubectl is the Kubernetes CLI, command line tool, which is something you write on your terminal like Docker and Git. Similarly, we have kubectl. Kubectl will communicate with the control plane. Okay, and like, hey, control plane, I want to start 10 applications or whatever. Control plane will be like, okay, let me see which worker node is empty or can handle the load. I will just start your containers over there. That is the use of kubectl. You can interact it with using like two ways. One is the declarative way, one is the imperative way. So declarative way, basically we create manifest files, you write YAML files, you write code in the YAML files, you give it that, and then it happens. Imperative way is something like you're telling your cluster for some specific commands and stuff, for example, right? So it's important to use the declarative way, because as many things as you can write in like files and stuff and not writing the commands again and again and again on the terminal, that's not really beneficial. So declarative way is very nice, and we'll see as well. So for example, you want to create a new pod, which is something we'll look into later on, and inside that you'll run a container. So in declarative, you will write a file in that. In the file, you will mention, hey, create a pod, this container, this image, this command will run whatever. Then you will give that file to the control plane via kubectl. So given this file, this is the declarative way. Imperative way means no file or whatever, I'm just writing commands in my terminal. So anytime you need to make changes, write commands or whatever. It's very tedious process. Okay, so now we have looked at two things in Kubernetes. We've talked about Kubernetes cluster, and we talked about that orchestrators thing. So now what is it? Is it a Kubernetes like cluster, or is it an orchestrator? Both. Okay, so when the cluster definition is that it manages a control, like a collection of control plane and the worker nodes, it's called a Kubernetes cluster. Orchestrator basically means is managing all the microservices. Okay, where are the microservices running? Obviously on the worker nodes. Who is managing that? Control plane. All right, let's see how that happens. Okay, now to an important part. When we talk about Kubernetes objects and stuff, Kunal, what are objects? So Kubernetes does a lot of things. Okay, scheduling our containers, scaling our containers, making sure a number of containers are running all the time, exposing the container to the outside world using, let's say, a URL. So when you type youtube.com, okay, youtube.com, it only sees you for you, it's only like, okay, youtube.com request was sent to Google sent me a response back. But internally, it's all working on containers. You type youtube.com, it will go to Kubernetes. Kubernetes will make sure, okay, Kunal has requested youtube.com. Which server do I direct the request to? So Kubernetes will direct the request. That will be an endpoint for your URL, some IP address allocation or whatever. Right? But for you, it's only youtube.com. So stuff like ingress, services in Kubernetes. So various problems that it's trying to solve has various tools or components. For example, these are known as objects. Okay, the simplest one that we are looking into right now is pod. A Kubernetes pod. Pod is nothing but a scheduling unit in Kubernetes. Scheduling unit in Kubernetes. So where does your application run? I mentioned already it runs in the worker node. So worker node is what? It is just a server. This is a worker node. Node is a server only. Okay, don't worry about that. And here inside this, let's say you're having your containers, Docker node, container D or something. And inside that, this circle is a pod. And inside that, this box is a container. Okay, make sense? So you have something like a container runtime, worker node. I'll go into details of worker node later on. This is a pod and this is a container. Make sense? Are you able to understand what a pod is? Similar to container, it's a scheduling unit. One more layer added. It's the simplest, smallest scheduling unit in Kubernetes, a pod. Inside the pod, you run containers. Okay, it's basically convention stuff, good practice that only one container, one pod or one type of service. So that again, the microservice example I gave you, as much as you can divide, it's better. Let's talk about how this Kubernetes applications run on, on the Kubernetes stuff. I'll talk more about pods obviously in detail. We'll also see a demo of pod in this example only. We'll try to run pods on your local system and also in the cloud. So I'll show you how to create pods and run your own application in pods as well. Okay, so make sure you stay till the end. Cool. How to start with Kubernetes and stuff, what all things go into picture. Obviously you need your application. So first of all, your web application or whatever you have, you create your application into a microservice. Means divide various components in separate parts. Part number one, create microservice. Okay, this is a step for running application in Kubernetes. Second point, what is the second point? Add every microservice in its container. Containerize it. It's not like you have 3 microservices, all 3 will go in one container, in just one pod. No, every pod will be different so that we can scale it individually and debug it individually and so on and so forth. Containerize it, very simple. What is point number 3? Put every container in its own pod. Put container in pods. What is the fourth point? Deploy these pods to controllers in Kubernetes. Controllers, something we'll learn about later on. Deploy these pods to controllers, such as deployments and stuff. In Kubernetes, there's another object called deployments. You can imagine it as like, it may be not 100% accurate, but like primitive data type and complex data type. Pod, you can imagine like in data structures algorithm, primitive data type, and you have, let's say, integer primitive data type and complex data type like arrays. So pod can be like int, and deployment, a type of a controller, can be what? Array. You want to scale your integers, you resize the array. So deployment is basically that. Okay, if you check out the official documentation of Kubernetes of controller, basically controllers are loops that watch the state of your Kubernetes cluster, then make or request changes where needed. Each controller tries to move the cluster state closer to the desired state. Desired state is what? I am telling Kubernetes, hey, I always want you to run 5 pods. So you will give this information to whom? A controller. What is one type of a controller? A deployment, for example. Deployment is one type of a controller. Okay, you can see something over here. The deployment controller. This is a built-in controller in Kubernetes. Okay, sound good? All right, so you can find more as well, but we'll be looking into deployment and all these other things. So deployment is another type of object that you can create that will make sure, okay, Kunal has told me, we'll do a dedicated video on deployment as well. So Kunal has told me that please, run 5 pods at all times. If one pod goes down, it will automatically restart it. How this thing works, who manages it, that we'll see when we cover the Kubernetes architecture shortly. Okay, right now we'll see that. But I want to make sure you know about what controller is. So controller is nothing, it's just making sure that your desired state is always met. And pod is a basic scheduling unit in Kubernetes. In the documentation, you can also see container runtime interface. We've already covered that, right? Let's move forward. Okay, so let's talk about it. Now we know about a cluster. A cluster is made up of what? Control plane and worker nodes. So these nodes, the control plane is also a node. It was previously called master node. These are nothing but like servers or virtual machines. That's why when I talked about containers, it's not like this or that. Containers versus virtual machines. Containers run on top of virtual machines. Okay, so this entire thing, the node itself can be a virtual machine, and you're running controllers on that. Sorry, your Kubernetes containers and stuff, pods and stuff, and all these things, objects on that. Okay, cool. So we talked about kubectl, kubectl. We downloaded, and installation also will cover later on in this video itself. But now let's talk about the control plane itself. What the control plane looks like. Okay, control plane. In the Kubernetes cluster, let's talk about control plane. Cool. Control plane, it's very simple. It's basically a collection of various components that help us in managing the overall health of the cluster. Anything that happens, you want to make sure that you want to set up a new pod, you want to create new pods, you want to scale pods, you want to destroy something, you want to expose something, you want to do anything, it will be managed via the control plane. That is why it's called the control plane. Okay, let's draw the diagram of control plane. This is what the control plane looks like. Here outside is my kubectl, which is my CLI tool. Via this I will communicate. I will be like kubectl create pod or something like that, right? So here we have an API server. I'll explain these components differently. So this is the architecture of control plane. So we have the API server. Kubectl obviously communicates with the API server. It's be like, hey API server, create 5 pods. Hey API server, this is a file that contains the definition for deployment. Please create this deployment. Please create this service. That will happen. Okay. There's one more thing that we saw in the previous lecture, etcd. In the Docker lecture, we saw this. It's a database, right? etcd. There's something known as controller manager. Talked about this. I showed you as well. Controller manager, but we definitely will talk about. These are just components. Okay. There's one more thing known as a scheduler. You can write it somewhere. Scheduler. These two things. Scheduler in control manager. Let's talk about how these things work. First of all, API server. Okay, API server is very simple. It is basically that all the communications that will happen via the API server. Okay, so it is basically, it exposes a RESTful API, and then you can give it a post in a post API. You know, like get post. You can check out my networking video if you don't know these basics. So over HTTPS, you can give it some YAML files. Like, hey, YAML file will contain something like, hey, create a pod definition, which container, which image, what you have to run. That all will be mentioned over there. Okay, so over HTTPS, you can post your YAML configuration files. These are also known as manifest files. The YAML file are known as Kubernetes manifest files. Oftentimes this can get very complex, but we can use tools like for free open source tools like Monokle, I've already made a video on that. It will make your life extremely easy when learning Kubernetes as well. Extremely easy. You would not have to write files, so many files on your own. It will do it for you, and it will make it very easy. I'll show an example of that as well. If you don't want to work with files, which I would highly recommend, do it when you're learning, because don't skip the basics. But you can also use Kubernetes Lens IDE. So it's a integrated development environment for Kubernetes. Without working with YAML files and stuff, you can create pods and all these other things. So I'll teach you that in this video as well, but I've created a separate video on that already. This is also free to use for you, so check it out. Okay, so all the requests will, the API servers will go, and API server will be like, hey, what's up? Like, you want to create a new stuff, and you can do that. No worries. It's totally fine. Cool. You want to create some pods, you want to do whatever. So your kubectl will talk to the API server, and all these scheduler and control manager also will talk to API server. Okay, cool. API server clear. Okay, etcd, it's a database. So like cluster store, like it basically stores the information about the cluster. So API server, if the API server wants to get any information about the server, it communicates like etcd over here. Okay, so basically what it is, it's basically a database that consists of state about, like, configuration about the entire cluster. Okay, information about the cluster. It's also an open source tool, etcd. You can check it out. All right, now comes into picture controller manager. What are controllers? Controllers make sure that the desired state that you want, say in my desired state I want 5 pods should be running. Controllers will take care of that. But who will take care of controllers? Control manager. So it's like a controller for control managers. Okay, so basically what will happen is it has 4 functionalities. So it has 4 functionalities. Desired state. You check the desired state. Okay, Kunal, what do you want? It'll be like, hey, to the API server, I'll be like, hey, I need you to run 5 pods all the time. API server will be like, control manager will be like, control manager will be listening to the API server. Okay, someone is requesting a controller for 5 pods. They'll be like, okay, I'll create that. No worries. Okay, it manages that. It manages the current state as well. What is the current state? Something go down. Kunal was saying 5 pods should be running. Only 4 pods are running. What is happening? Right? So these are like control manager, creates control like loops, the things that I just showed you in the Kubernetes documentation also, that does this. Next thing is, you can check out some of the differences. Okay, so it constantly listens to API server. It's like, okay, someone is requesting any changes to the deployment or whatever, it will make those changes. So make the changes. Cool. That's basically control manager. Okay, very simple. Okay, last but not least, we have the scheduler. So this is the one responsible for physically scheduling the objects and stuff. Schedules stuff as the name suggests. So for example, it is always also listening to API server. I will say API server, hey, please create some pods or whatever. Scheduler will be like, okay, Kunal has requested some pods, and this is the reason. Scheduler is the one who is going to schedule it on worker nodes. Scheduler will be like, okay, let me see which particular worker node is empty or best suited for it. We'll schedule it accordingly over in the worker node. So scheduler's responsibility is that. It's too simple, not making it any complicated, very simple. That's basically it. Okay, so it will check out all the healthy nodes and everything and put our tasks or whatever on top of that. Cool. So scheduler has like some criterias, right? So it has like container is creating and scheduling and its pending state and whatever. So if you cannot find a worker node, for example, it's like, hey, schedule 100 pods or whatever. It's like, hey, but I can't find a worker node that is, free to do it. Okay, free to do it, for example. So it will say it's pending now. Okay, cool. So beforehand, it will check the node that you're trying to schedule on. Does it have some free resources? Are there any networking requirements? And do you have the images for running the containers, or do you have to download it? What is already running on that node, and so on and so forth. So in that case, then it allocates your tasks to some nodes up accordingly. Okay, the control manager, one more point I want to mention is that if you're using some cloud providers, they'll be using their own control manager, right? So that they can work with like load balancing and stuff and all the other additional underlying features. Cool. So that's basically about it. And since this is just a API server is listening to HTTPS requests. It listens to it on when you make a post request, HTTPS port 443. If you don't know about these basic stuff, please check out networking video. It's very important. I did that complete networking course. Awesome. Okay, control plane is clear. Now let's take a look at worker nodes, how worker nodes work. So let me first draw it like, a complete architecture, let's say. So we have kubectl, which is the CLI tool. We have your control plane, control plane. Control plane has the API server. Cool. You have etcd. Okay, we talked about that. You have your controller manager, right? You have your scheduler as well. Okay, we already talked about all these things. Let's talk about what the architecture of worker node looks like. Worker node. So worker node has a kube proxy. We'll talk more about this later. Kube proxy. Okay, kubelet. Okay, and a container runtime. Container runtime. Okay, and this basically communicates with the API server, and this also communicates with the API server, and kubelet communicates with container runtime. Container runtime, you already know what it is, but these two things we don't know. So let's see. And this is running on top of some Linux. This is also running on top of like Linux. Okay, this is your hardware. Control plane. Same thing for this. These can be different computers as well, different servers. Obviously, not can be, it probably is. Okay, now let's talk about these three things. We don't know what these three things are. So let's talk about it. The kube proxy, kubelet, and container runtime. All right, let's talk about kubelet. So kubelet basically is very important. It's on every worker node. So whenever a new worker node is created and attached to the control plane, the kubelet is installed on that. Okay, the job is that it will basically listen to API server. It's actually talking like this. So I'll say via kubelet, via kubectl CLI, I'll be like, hey, create some pods or whatever. Kubelet is always going to listen to the API server, and it will be like, okay, you are requesting something. I'll allocate those on my own, like node like this. That is the only rule. Okay, if it is by chance not able to do it, that's why it's communicating with container runtime. This is actually where your, let's say I write it in a different way, your container runtime like this. Container runtime. This is a pod. This is a container. Now it makes more sense. Okay, so it will always listen to API server. It will be like, okay, I can schedule it on my own, no worries. If it cannot do it, it's not going to do anything. It will just report back to control manager, control plane. I'll be like, hey, I can't schedule it on me. Like, please do something else, whatever you want to do. Then API server will work with like the scheduler and control manager, like the scheduler, and be like, okay, this particular worker node is not able to schedule it. Let's do something about it. Okay, so that's kubelet. Container runtime, we already saw. Basically, container related things are done by it. So what container runtime does, let's say we learned about Docker, everything Docker stuff that will be done over here. But in Kubernetes now it uses containerd. Containerd also we looked into the previous lecture. Very simple, pulling the image, pushing the image, creating a container out of it, and stopping the container, destroying containers, and all these things happen. Okay, so that's basically about it. So in Kubernetes, previously there was support for like Docker and stuff, but then came into picture something I already mentioned, container runtime interface. So that is why now it's the Docker thing. It has been replaced with containerd, okay, which is also a CNCF project. And why? Because Docker does not support CRI, which is container runtime interface. Already talked about it before. So basically an interface so that you can use various container runtimes, but container D supports it. So that's why it's being used it like that. Cool. All right. What else is remaining? Kubeproxy. Kubeproxy is very simple. It is something that is responsible for networking. So if your worker node or your cluster wants to communicate with outside network, kubeproxy will help in that. Okay. So for example, kubeproxy will make sure that every worker node and stuff that you have will get its own unique IP address. This will provide IP address to nodes. IP address to nodes. So every node will have its own IP address. We will dive deep into this in Kubernetes networking. If you want, you can Google it yourself. Kubernetes networking. So many books available on it and everything. Little bit of complex topic. I'll try to make it simpler. So please make sure you like, share, and subscribe. And we'll do a video on Kubernetes networking very soon. Okay. So all the things like load balancing and stuff, it manages all the things. The kubeproxy stuff mentions. So when someone asks you about kubeproxy, you mention it deals with like the networking part of my cluster. Okay. What about interpod, like cluster communication? You have a cluster like this. Okay. And in that, let's say you have 2 nodes like this. And in that nodes, you have pods, 2 pods, 3 pods or whatever. Okay. You want to like communicate with each other and stuff. This wants to communicate and all these other things want to happen. Kubernetes has its own, internal DNS service. So K8's DNS. This is based on core DNS. You can also Google this, but we'll cover this in the networking part. It's just a basic understanding. So it basically has some IP addresses for every pod, and all containers and pods know like, how you can communicate with each other. Okay. So what is DNS? We have covered this in the networking video. So whenever you create a new like service and stuff, it basically automatically gets registered into that. So it's very important when you talk about like how to communicate with each other, but obviously this is not a complete tutorial on that because I have to dive deep. I'm not going to explain this right now because I would have to explain to you about services and ingress and all these other things and core DNS and stuff. But if you are interested in exploring yourself, do it. If you're not, which I would highly recommend you should, but if you're not, if you want to learn from like me, I'll cover it in the dedicated video called Kubernetes networking. Check out the Kubernetes playlist. I'll upload it in that very soon. Okay. So that was it. Yeah, that's the architecture and everything. Mostly we'll be working with this thing, like how you can create it. So in order to better understand it, like this particular point, you can imagine it something like this. You can say that there's a container like this. So this is a container like this, which is running inside a pod like this. Okay. So pod is a scheduling unit in Kubernetes, the smallest scheduling. You cannot schedule a container without a pod. Okay. Pod is the smallest stuff. Okay. And you can schedule pods inside a deployment. Okay. This will scale your pods, update your pods and all these other things. All right. So this is the sort of like the architecture, this one that will be following. But let's first look into before the deployment stuff. Now let's look into the very basic stuff in Kubernetes is pod. So let's look into how you can start a pod and start a container in that or whatever. And also let's look into how to install Kubernetes and use it and stuff. All right. So now let's look into installations. What all things you need to install. Installation. Cool. The first thing is the Kubernetes like command line tool, kubectl. Okay. The CLI, this one, this thing over here, we need this. So just go to this website and you can install tools. You can install kubectl, install for Linux, Mac and Windows. I've already made a video on Linux commands and how you can add stuff into like path variables and stuff. It is relatively easy, very straightforward. For Windows and stuff, you can check it out. You can just use the curl command and just add it in your path and that's it. Done. Very simple. Okay. Kubectl. That's the first part. You can do that. It's very, very easy. I'd also recommend you can check out Docker Desktop. What happens is that Docker Desktop we saw in the previous lecture. So the second part that way you can do is Minikube. Now Minikube is great for testing purposes. Why? Because it offers a one node cluster. What do we mean? Kunal, you're saying that in the Kubernetes clusters, you have two nodes. One is the control plane, and you have a few worker nodes. So let's say you have one worker node. Minimum you need two nodes. How are you saying that Minikube will only give me one node? Will it be worker node or control plane? It will be both. It will act as both. So for testing purposes, you can install Minikube. You can do this via Docker Desktop. Docker Desktop, you can use it for free, and it will help you it will also give you kubectl. Okay, so I would recommend install Docker Desktop, and it will give you access to kubectl and also Minikube. So for testing purposes and stuff, you can use that. Cool. And if you don't want to do that, you can also install Minikube on your own, like from over here, and you can use it from you can check out the getting started guide for Minikube. You can install it, and you can see what it's required: minimum 2 CPUs or more, 2 GB of memory, and something like that. Okay, and also virtual machine manager. So you can use either Hyper-V or something, or VirtualBox, whatever you want. If you're using M1 MacBooks like I am, for local stuff, you can use Minikube. That's the second option. Okay, it's very simple to get started. You can use, in Windows, you have what? WSL, Windows Subsystem for Linux, very simple. So everything is mentioned over here. So you can just check it out. It's an extensive guide, and I would highly recommend you to check it out. It's kubernetes.io. Tasks, install tools in the documentation part. kubeadm is also something you can install, but you don't have to. Don't do it. No worries. The third part is, I'm just going to write it down over here, just listing out resources for you. kubeadm. This is the best option. Cloud provider. Why? Because in Kubernetes, we'll be working with multi-node infrastructure that you cannot set up on your local system. You would have to use cloud providers. You have to learn something. You would have to get into the resources. Okay. Some pointers I like to give you is we're going to be using Civo. Why? Because it's low cost and very, very fast. Faster than like AWS and stuff. And I also work at Civo, so that's like, you'll be like, Kunal, you're just saying it because you work at Civo. That is fine. I don't mind. You can use whatever you want. You want to use AWS and stuff, go for it. But when your bill comes out to be like $100 and stuff, then don't come running to me. Okay. Civo and same stuff that will take AWS to start a Kubernetes cluster in, let's say, 10 minutes, 15 minutes. Civo will do it in 90 seconds. It's extremely fast, extremely cheap. You also get $200 worth of free credits. So you want to start up with multi-node infrastructure, you would have to use a cloud provider. Point is, some people are so annoying. They're like, Kunal, they are asking for credit card information. You are, is this a scam? Is this a what? You are students. Please, if you had learned some basic cloud computing, you would not be making such weird questions. For security purpose, every cloud provider, they have to add a card. Go to any cloud provider, AWS, DigitalOcean, Linode, Civo, Google Cloud, and Azure, AWS, whatever you want to go to, Alibaba, they will ask you to put a card when registering for it. It is basic cloud computing. Okay, no one is running from your money. It's like security best practice. Okay, so it's not like some like a promotional stuff. I'm just saying it's very good, cheaper than all the other alternatives, and very fast and extremely simple to use. And I'm going to be using it in my courses. But this point was just for some folks who say, oh, they're asking for card. Though I don't have time for such questions. Okay, this is a very nonsense question. Obviously, they need card because it's a cloud hosting platform. For security purpose, they need card. So please don't annoy me with these questions. Okay, you can use whatever platform you want, and you will not have any like issues and stuff. Do whatever you want, but be sure that you are not leaving a cluster running so that your bill is increasing or whatever. For now, for the basics to follow this course, Minikube is fine. Okay, free version, Minikube, run it on your own system, totally okay. If you're just learning, you don't have to go like for a cloud provider or whatever. Okay, so does it mean that if you're not using cloud providers in this course, you will miss out? Absolutely not. You can use Minikube when learning, no problem. But in the future, later on, when we do multi-cloud stuff, in that case, I'll let you know. That will also be free. You can use $250 worth of free credit. And it's very cheap as well. Just Civo is like just $5 a month. So right now, no worries. You can use Minikube. Right now, I would recommend you do this thing. This thing, free. It's free. Okay, that is what I'll recommend. Civo also has a civo.com/academy. You can check it out for more Kubernetes courses and stuff. Cool. So download the Minikube stuff, Docker desktop or whatever, and you can see it on the screen over here. You can install the tools over here. So for now, just do Minikube and let's get started. Okay, so once you have Docker desktop and kubectl and everything installed, I can say kubectl. I can check the version. This is same for all. So as you can see, my version is available over here. Cool. So this is not looking very good. Like the output is not very nice. So I can say output is equal to YAML. This looks much better, right? Major version, minor version, build date, compiler, git commit, and all these other things are mentioned over here. Sound good? So that's basically about kubectl. Once you have Minikube installed, you can get that some commands on that as well. Okay, and you can create a new Minikube cluster. You can just say Minikube start, and if you're using VirtualBox, you can say VM driver is VirtualBox, but I'm using just the Docker one, so it's going to take it on its own. And that's it. The starting stuff and creating a cluster stuff is mentioned in the Minikube documentation for Windows users, like how you can get started as a Windows user. So if you're using Hyper-V or whatever, there are some steps with that. You can set up like a VM driver, if I'm talking about VM driver, you have to set up like equal to Hyper-V or something. So check out the documentation. I don't have Windows installed over here right now, but it's very simple stuff. Minikube start. Saying you using the Docker driver based on existing profile, starting the control plane node Minikube in cluster Minikube. So one cluster will be created and it will allocate some resources to it, and it will be basically one cluster will act as control plane and worker node both. Okay, so it's pulling the images right now. So what is happening is that it's creating a new virtual machine based on the Minikube image. All right, so this is going to contain a few binaries and stuff and container runtimes and all these other things and everything basically that is required to run Kubernetes. So it's just a single node cluster only, and you can also run Minikube stop as well. To stop the cluster, you can run Minikube. I think there's a delete command as well. Minikube delete you can run, right? So it's running and it's saying it's missing, so it's creating it. So you can see it's allocating 2 CPUs and around 4 GB of memory. No worries, it's creating that using Docker desktop, so it's using the Docker container. No worries, should take a little bit, not that long. Let's see. There's nothing, it's just a cluster, one node cluster, Minikube, that's it. That node has 2 CPUs and 1 memory, 4 GB memory. Nodes are nothing but virtual machines and servers. That's it. Taking some time over here. It's also given the GitHub repository over here, so you can check it out, the releases and stuff. Preparing Kubernetes version on this thing. Because I'm using Docker desktop, so it's using that. Alrighty, let's see. I believe I haven't updated mine either, so I'm using maybe an older version, but you can update yours. I'll do it as well. That looks good. That looks good. So it's using these images. You can check out the images as well. You can check out these on the hub, Docker hub and stuff. And I think that is it. In the default namespace it has created. Namespace is something that we'll cover later on. Don't worry about namespace right now. But let's see Minikube status. All right, control plane running, host running, kubelet running, API server running, and kubeconfig is configured. All right, kubeconfig is basically a file that has some information like some secret information that if anyone gives you that kubeconfig file, if someone gives you the kubeconfig file of your Kubernetes cluster, you will be able to access their Kubernetes cluster. Basically, that's what kubeconfig file is. Okay, I'll show you a little bit of kubeconfig file in this video itself. So that's one way, like running Minikube. You can say kubectl get pods. Right now it will say no. Okay, these pods are running. Cool. This is actually previous pods that I was running. Okay, so if you run it for the very first time, it will say nothing. Okay, you can also check out the nodes. Only one node, Minikube, which is a control plane. Very simple. All right. Kubernetes also has a dashboard built in, so you can say Minikube dashboard, and it will open up this dashboard on localhost. So via this dashboard, you can see all the deployments being created for me, pods that I created previously, right? I can delete the pods as well, delete it. Okay. Replica sets, controllers, jobs, deployments, or whatever. These are just various workloads. We have already learned about pods only. These are just some different loads and stuff. Services, ingress and service. So ingress is basically used to, you know, expose your application. Service is also used for exposing applications internally. Config map, secrets is used to store some passwords and stuff. All these videos will be doing individual videos, volumes, and all these other things. Only Minikube node is available. You already know what a node is, right? So you can access the dashboard as well using Minikube dashboard. Okay, let's explore some of the commands that, you know, like Minikube has to offer. So you can also check out some like environment variables and stuff. You can say Minikube. I can say docker env. It's gonna give me some environment variables, and basically it's same for when we work with like dockers and stuff. But yeah, that's basically about it. It's basically like these are the variables that are required for your client, the Docker client, to the local one that is installed on a computer to communicate with some remote servers. All right, so that's basically about it. And in this case, as you can see, Docker is running inside a virtual machine. So that's the like Docker server that is running inside the virtual machine. Cool. And you can also check out the Docker containers that are running. You can say Docker container ls. So these are the containers that are required by Kubernetes. Okay, this is a container, this is the image as well. Everything is mentioned over here. This is the one required by Kubernetes. All right, cool. So one more thing is that one more thing I want to show you is that everything that is running inside this virtual machine is running inside a container. So I can check out all the containers that are running in Minikube as well. I can SSH into Minikube, go inside Minikube, and now if I write over here, because inside Minikube it installed what? Docker runtime. So I can say Docker container, or I can say Docker TS, all the containers that are running. So you can see these are all the containers that are running. Cool. Sound good? Because I ran it previously. Via some pods are running already, right? So if I show you something like, if I see some pods that are already running, let me show you how to run the pods and everything. If I show you kubectl pods, sorry, get pods. What am I doing? These are already running. Inside these pods, some containers are running, right? Here are those containers. So you can check it out like that as well. Cool. Exit. All right. So one more thing you can do, you can say kubectl config. Oops. Kubectl config view. I think this is my kube config stuff. All right, it has information about my cluster. Sound good? Cool. You can also get the current context Minikube. Okay, and you can get nodes and stuff. I already mentioned that already. So in my Kubernetes cluster, because I've been using it for a while, I was testing out some things. Some pods are running, some deployments are running, some services are running. Okay, I will teach you how to run these individually also. But let me see, like if I want to say kubectl get all, these are all the pods that are running. These are the services. These are the deployments. These are the replica sets. So imagine, like, do you remember when I talked to you about deployments? Container inside a pod, pod inside a deployment. With the deployment, I say, hey, deployment, I want you to run 4 pods all the time. So that is basically what it is. Let's say Nginx deployment is something I created. How to do it, we'll cover later on in deployment section. Right now, understand see in it happen in real life, what I was mentioning. So here in this deployment, I'm saying always have 4 pods ready. So Nginx deployment, here you can see 4 pods are always running. Okay, so to the deployment, I said that always run 4 pods. If I say kubectl get pods, here you can see Nginx deployment is always running 4 pods. If I try to delete this pod, kubectl delete pod, pod is deleted. Okay, get pods. Now you can see that it started it again. It started it again. Why? That entire picture I showed you, entire picture, right? The control manager, always listening to API server. You're like, oh, Kunal said that I am running a controller deployment. Deployment is a type of a controller, I've already mentioned. And he was like, oh, always run 4 pods. But some 1 pods went down. I would have to start one again. This is a real life demonstration of the architecture that I mentioned. Make sense? Cool. So whenever I delete this pod or whatever, it will already do it. Okay. So I can say kubectl get deployment, Nginx deployment, I can delete it. Deployment is deleted. So you can see pods are also now terminating. Why? Because deployment was deleted. So the pods of the deployment are also gone. Don't worry about it, like if you don't know how deployments work or pods work or whatever, but I just wanted to mention that. Okay. That is what we have over here. Very easy stuff, right? And you can see it works on port 443. I mentioned it already. So that is it. Let's move forward and see some more commands and stuff. So yeah, I believe basically that is about it. You can also, when you're starting Minikube, you can also specify like Kubernetes versions and stuff, and all these other things. Cool. So that was one way to run Kubernetes Minikube. Okay, now let's talk about some tools I want you to install because this will make your life extremely easy, and we'll be working with these, and these are all free. Okay, you don't have to pay for any of these that I'm just going to mention, and this is going to make it extremely easy for us to like learn and collaborate. So for example, Minikube, right? I just ran Minikube over here. I can go to Lens, and I can go to my clusters, and I can go to Minikube, can connect it. Okay, so you can see all the CPU memory usage of my Minikube, all the pods that are running in Minikube, all the deployments in my Minikube, right? I can check out all the information about my pods, and how to create these pods and everything we'll check out later on. But basically you can say create resource, and you can say I want to create, let's say, a pod. So it automatically gives you the template. You don't have to write it down again and again. How cool is that? You can also connect it with your online clusters. If you're working with like cloud providers like Civo or AWS or Google Cloud or whatever, Azure, whatever you're working with, you can connect it with your cloud provider also. So this Lens demo, I've actually done a video on this, so you can check out Lens IDE, check out the documentation. Best way to get started is check out my video, Managing Kubernetes Clusters with Lens. It's a 30-minute video that will get you up and running with Lens. So check out the link for this in the description. I mentioned that. It's an extremely handy tool that you can use to get these nice dashboards and stuff, and you can do all sorts of things, all the things you can mention without working with, let's say, YAML files and stuff. So very handy. So make sure you check that out. Second one is KubeShop. So KubeShop, also I've done a video on KubeShop. Basically it makes it easy for us to debug and manage our manifest files. So when we work with complex, if you don't know YAML files, basically in this video itself, when we create these Kubernetes objects and stuff, pod and everything, we use YAML files. Okay. So if you don't know how to work with YAML files, I made a video on that as well. You can go to the DevOps bootcamp playlist on my YouTube channel, and you can check out the complete YAML file course as well. But when the YAML files become really big, it gets difficult to manage those, and KubeShop helps us in doing that. All right. So KubeShop has a tool called Monokle where you can manage and debug your Kubernetes manifest files. I've also made a video on that. You can check it out. Okay. And this is what the Monokle dashboard looks like. So basically I can select the kubeconfig file. So as you know that by default, the Minikube kubeconfig file, or by default any cluster or anything you're creating, the default kubeconfig file is in .kube/config in your home directory. Okay. Now don't ask me a question about what is a kubeconfig file. It just contains information that will be relevant to access your cluster. If I am creating a cluster on Civo and I download the kubeconfig file of my cluster and I give that to you, you will be able to make changes to my cluster. I can say show cluster resources. So you can see it has 4 daemon sets, these deployments, and what these deployments are linked to. So I can see that this particular deployment is linked to this. So you can see such a big file, right? Such a big file. How difficult would it be to like go through this entire YAML file? But no, 32 pods and stuff, everything. Monokle by KubeShop. It's a free tool, open source tool. You can give some feedback over here as well. Join the Discord channel and stuff. So you can see it basically translates this into a really nice navigation form. Okay, and I've made a video on this as well. Over here, manage and debug manifest with Monokle. Cool. Similarly, one more tool we'll be using heavily is Kubescape by Armo. So as you can see, it's an open source tool providing a multi-cloud kit, single pane of glass, and it includes risk analysis and security compliance, RBAC visualizer, and vulnerability scanning in your images and stuff. So check out the link in the description as well. It's very easy to install. Just install on Windows and Mac OS, and simple installation. All right, and you can use your run your commands and stuff. But you can check out their Discord channel as well. You can check out some of the examples and tutorials are mentioned over here as well. So it's extremely easy to get started. Make sure you give them a nice little star and fork it, and you can contribute as well. You can check out the open issues, but please make sure you check it out and get a head start, because we will be covering this and it will help us quite a lot when working with like, your Kubernetes clusters and YAML files and Helm charts and stuff, and detecting misconfigurations. So it's pretty awesome and it's going to help you quite a lot. So do get a head start and check out the link in the description. The next one is Datree. Such an amazing tool. I've actually made 3 videos on this. The basics one, how to use the Helm plugin, how to add your custom rules. So basically the idea is that sometimes when you're creating these Kubernetes manifest files, right? So what happens is that you may add some rules that were like, you may violate some rules. Okay. So in order to resolve that, I've they've created Datree for that. You can get started for free, and you can basically, it's extremely easy to use. It may look like it's like a little bit complex if you're just starting out, but nothing is to be worrying about over here. Just a 29 minutes video. Check this out. And here, for example, this is a YAML file. You can just say test this YAML file. So once you test this YAML file, you can just run this command, Datree test the file path. Okay. Once you run that, enter, as you can see over here, it will be like, okay, 4 tests are failing. Okay. So when you work with such big YAML files, as we worked in the Monokle over here, it may be possible that you make some errors. Easily you can check those errors via Datree. So again, you can check out the link in the description and get started for free. Last but not least is also Teleport. Make sure you check it out. You can quickly access your infrastructure in like Kubernetes and services extremely easily, and it's pretty awesome. It also provides this nice little dashboard, and we're doing videos on that as well. So make sure you check out the links in the description. That was about Minikube, and you can also use Civo or any other cloud provider you want, but I would recommend Civo. It's extremely easy to use and cheap as well. Not like cheap as in, but what I mean by that is low cost. Just $5 a month, for example. Launch my first cluster, extremely easy to do that. Kunal demo. 3 instances means 3 nodes, for example. Network, default, everything default. Medium size, for example. And I'm going to say monitoring. I can add some Pyroscope or whatever, or Prometheus operator management. Just create my cluster. In under 90 seconds, my cluster, 3 node cluster will be created. On Minikube, you only have 1 node, but here I have 3 nodes. Okay. For learning purpose, for following this bootcamp, it may be not required for this. It will be required for some advanced stuff. What I would recommend is if you can work with Minikube, that is totally fine. Go ahead, work with Minikube. If you are able to do any cloud provider, whatever, make sure you do that. But in case you're not able to do it, not able to add your card or whatever, Minikube is more than enough for learning purposes. So in under 90 seconds, you can create it, and then you can download the kubeconfig file and save it and add it on your lens as well. And I've created that actually in the demo as well. I showed you both in Monokle and Lens how you can attach your Civo or other cloud providers Kubernetes cluster to these tools locally. So make sure you check it out. You can do that via just download the kubeconfig file that will be listed over here. Okay, now you have Minikube running and everything is running fine and stuff. Now let's get to the main part, hands-on demo. How do we put applications inside containers and that in pod and run the pod on our Minikube nodes or whatever? Okay, let's do that. So I'm just going to show you how basically like basic stuff of how it works. I've actually made a blog on this, written a blog on this, getting started with Kubernetes. It's a little bit of an older blog. So as you can see, the naming convention stuff, it's like I wrote it in my freshman year around that time, but it has a good example of the complete like about pods and stuff and how all these things work. But I'll make a dedicated video on this, but I want to make sure like I explain how these things, like how to basically create a pod, for example. So I'm just going to copy this file, and this is basically a manifest file, a Kubernetes manifest file. Same stuff we were exploring with what? With Monokle. So API version is V1. API version basically defines the version of the Kubernetes API you're using. V1 means that it means that the Kubernetes object is a part of the stable release of the Kubernetes API. So it can consist of core objects like pods and stuff like that. Some may be deprecated and stuff, but make sure you check it out in the in the official documentation. And apps V1. So if you're saying apps V1 over here, the version, it includes functionality related to running apps in Kubernetes. Batch V1 means consists of objects related to batch processes and jobs like task. These things keep on changing. Stuff keeps getting replicated and new stuff keeps coming. So I would highly recommend check out the official documentation. Then comes the picture into kind. Kind means what type of resource you're trying to create. So I'm trying to create, let's say, a pod. So I'm just saying pod over here. That's it. Very simple. Metadata. Metadata contains some data that helps uniquely identify the object, in that case a pod. So if you want to identify the pod in a unique way, you can include a name for that, a namespace for that, and some labels you can attach to that pod. I'm just attaching a label, like I'm giving a name Nginx pod, and I'm attaching some labels. So metadata contains stuff you can add, and this is obviously a YAML file. Okay, so this syntax is a YAML syntax. Check out the YAML video. So I'm just saying add some labels like, okay, app is running in this Nginx, tier is dev. You can also write prod or whatever. You can add your own labels you want. Spec basically contains the format of the object specs, like for every Kubernetes object. So for example, what type of containers you're running in it. So it's saying, hey, inside this particular pod, some spec, I'm only adding some containers. Image is Nginx container. Sorry, name of the container is Nginx container. Image is Nginx. This will always take it from the hub account, okay, remote account. So I'm going to copy. These are very simple stuff. Okay, if you're creating a deployment, you will add deployment over here. But as we move forward, I will teach you, I will make a dedicated video on every single Kubernetes object. Pod, I will make a dedicated video on that. We'll see how the pod networking works, how it gets scheduled, deployment and everything, services, ingress, and all these other things. We'll be creating dedicated videos on that. But the overall idea is same. API version, kind, metadata, and spec. Basic stuff. Copy. And I'm going to say, let's say I'm going to go to my desktop and I'm going to say mkdir project. I'm going to go into my project and I'm going to say touch pod.yaml. Okay. And I'm going to just insert it like this over here. That's it. Okay. Let me check my current pods. kubectl get pods. So right now these pods are running. Okay, Nginx one is not running, so no problem. We'll just run that. So whenever you want to create an object out of a file like this, you say kubectl create -f, the name of the file. Okay, kubectl create file pod.yaml. Pod.yaml. Pod created. kubectl get pods. So you can see container is being created for this Nginx pod. It's actually work in progress right now. Let's look at it again. It's running now. Nginx pod is running. Simple. That is it. That's how you can create all the stuff. Cool. You can also check out like some more information. kubectl get pod, nginx pod, like that. You can get more information with output wide, IP and node that is running on, so running on Minikube and stuff. Very simple. Okay. Cool. You can also get it in the form of JSON and YAML. Let's try YAML. Copy. Get pod name. Very simple. That's it. All the information provided over here for it. Okay. We'll go through all these things when we deep dive into pods. This is not the end of pod. We are only going to be like, we're going to be like working with pods a lot. Okay, you can also display the details of pods, which includes like all the events and stuff, like when the pod was created, time events and stuff like that. Very easy. Okay, age is mentioned, how it happened and everything. Okay, so this pod is running on Minikube. I can go inside my Minikube. So now I'm inside my Minikube and I can say, I can ping it. So I can say ping. What was the thing? Yeah, it was this one. Works very well. Very easy. So I'm inside my Minikube right now. Okay, inside the Minikube, I can talk to everything that is happening inside, right? Okay. Exit out of it. Very easy. Cool. Okay, you can export it using node port service and stuff. This stuff I'll cover later on, like how to expose and everything, and you know, all these other things and stuff like that. But don't worry about that. We'll cover that thing later on, how services is. So basically, if I want to access the nginx portal on my local host, for example, similarly what we did with Docker, port forwarding, we know it's running inside the container, but how do I access it on my machine outside the container? Forward the port. Okay, so I'll teach you how to expose the services and stuff and ingress to a URL and other applications, how these pods communicate with each other, how various worker nodes communicate with each other and everything. But right now, let's just do a simple port forward. Port forward is very simple. We did that in Docker. Basically, whenever I go to port 8080 of my local host, you should go inside the nginx pods port 80, because nginx runs on port 80. So this pod is running inside, you know, this, everything is, you know, in containers and everything, you know, it's Linux only, running on top of Linux. So we can go inside this pod and we'll be able to execute Linux commands and everything. So enter. That's it. Now I can go to localhost port 8080 and we should be able to access nginx. Ta-da! So I'm at localhost port 8080. And as you can see that I'm able to access the nginx. This is actually running inside Kubernetes in my pod, nginx pod, inside that a container. And I'm accessing it via, as you can see, it's giving me outputs as well. Refresh and see outputs as well. Simple port forward. Localhost forwarded to nginx pod port 80. Please don't be confused like what is inside this container. You know, right? Whenever an image is downloaded, even nginx image, it will have some Linux in it or an operating system available in it. So inside every single container inside will have an operating system in it. How cool is that? Very nice stuff. That is Kubernetes. So now if I stop it, now I'm not able to access it. Okay. So that was about Kubernetes. That's it. This is the entire thing. I hope I made it easy for you to understand if you have watched the Docker video and networking video as well. But I made it as easy as possible to understand it. And don't worry, this is just the beginning, basic of it. Now the real work starts, which we'll see how various Kubernetes objects work, like pods and deployments and everything. And the most important part, will be also seeing such tools and tools, because it's all about CNCF, you know, the landscape and stuff in cloud native. So let's see. You can check out the CNCF landscape. These individual blocks that you see, these are projects. So many projects. Service proxy has so many projects. API gateway has so many projects. Service mesh has so many projects. Linkerd and stuff. Kubernetes will be available here as well somewhere. So the container registry and stuff is available over here. Scheduling and orchestration, there's Kubernetes. There's crossplane and stuff. And monitoring we have Prometheus, Thanos and Cortex and stuff. So on this channel, Helm, I'm actually wearing a Helm hoodie right now. We'll do videos on Helm as well. So you can learn about all these things and everything, but what I'm trying to make better, like with my YouTube channel as well, is we'll be doing a deep dive on these landscape and various tools. Some of the tools like that help you in your Kubernetes journey, like Some I already mentioned resources in this video, and these are important to be knowing if you want to step into this field. We work with these daily, these communities, we work with them, we see what all things are coming out new and stuff. So just one thing will not help you. And it's not like you have to be a pro in every single of these technologies. I know it sounds overwhelming. That's not required. No one knows all this entire landscape. No one knows that. Okay, it's very complex. But having a good overview and of how things, important things and popular projects work, I think that's important. And my channel will help you in that. So hit that like button, subscribe, share, comment right now, and that's it for this video. Make sure you take a screenshot. Kubernetes is a great topic, a new beginning for you all. And I'm super happy that you understood, whatever we covered in this video, we'll cover more and more such stuff. Now it will be not that difficult. It will just be like, once you have a basic understanding, it will be very nice and fun. After this, I'd recommend you to check out so what is the next step? Wait for the next videos, check out the Kubernetes documentation, check out other nice contents, and highly recommend after this video, watch the cloud native tools deep dive video. Now you'll be able to understand that. Datree, Kubescape, I'll do Teleport and Kubescape and Lens and everything. You will be able to understand that now because you know Kubernetes now. Okay, so watch the cloud native tools deep dive, and then I'll add more videos in the Docker and Kubernetes playlist. And subscribe, share on Twitter, use hashtag with DevOps with Kunal. The Twitter bot will retweet it. Join the Learning in Public initiative. Write a blog on this. It will be awesome. And check out my newsletter as well. If you want to support, it takes a lot of efforts to create these videos. So if you want to support, check out the link in the description and check out the videos, like the video, subscribe, share, comment. It will help quite a lot. If you comment, then it will reach more and more people. And one more thing I want to mention is that if you share it on socials, then other people will find out about it. And follow us on socials and Instagram and Twitter and LinkedIn and stuff, and tag us so that we, it reaches awareness, community classroom and me as well. That's all we require. We don't require your money or whatever. Everything will be free forever and in detail as well. And I'll see you in the next one. Have a great day. Make sure you share, and I will see you. All right. So have a great day and